Hello everyone. In our last video we have seen about NS logs and semaphores, using which we can do the synchronization, which are for thread safety. Basically these are synchronization techniques like logs and semaphores, using which we can control the access to the shared resource or critical section of a piece of code, so that deadlocks or race conditions will not occur in a multi-threaded environment. So we have seen example for a log where we initialize an NS log and we lock it, and once we are done with the resource, shared resource, here the mutable count is the shared resource, so we access it, and after that we unlock it so that it will be available for the next thread. So that example we have seen, and also semaphores we have seen. So semaphores almost similar to logs, but there are some differences which we are going to discuss in this video tutorial, where you create an instance of dispatch semaphore. You give a value of 1 indicating how many threads can access a shared resource or a critical section of the code at a time, and you can wait when you are accessing the critical section of the code, and you can signal to release the log. Wait is nothing but acquiring the log, signal is nothing but releasing the log. So that's the basically the difference between log and NS log. So we have seen these examples. Okay, in this tutorial let's see some of course logs and semaphores are similar. We will see what are the major differences between logs and semaphores, so that we can pick up the correct synchronization technique based on our requirement. So let's go ahead and see what are the basic differences between NS logs and semaphores. Of course both are synchronization mechanisms in Swift that are used to manage concurrent access to shared resources, but while they serve a different purpose, there are some differences between NS logs and semaphores. So we will discuss what are those differences. So basically I'll write it down. So let me write them here. So first of all, coming to the functionality, NS log is a simple log based mechanism that provides mutual exclusion. So that means it allows only one thread to enter at any point of time. Only one thread can enter the critical section at a time. So other threads, until the lock is released, they will be blocked. So mutual exclusion, sorry, only one. Whereas considering the semaphores, these are more versatile. These are more versatile synchronization primitives, can be used to control access to a shared resource with a specific number of permits. Here I have a value, I can increase it, I can say like okay 3 threads can value, no harm, 4. So it's based on my requirement. Okay, so with a specific number of permits we can say, why? Because they maintain a count and allow multiple threads to enter a critical section simultaneously up to the available number of permits. Okay, for example, let's see, as an example here we have seen, if I give the value of 1, so what will happen? Let me comment, let me move the semaphore course to the beginning, go to the beginning, and let's see the example of semaphores. Okay, if I run the semaphores, so it has picked up document 2, completed, started document 1, completed, started document 5, completed, started document 3, completed, document 4 started, completed. So only at a time that critical section of the code can be accessed by only one thread. So I can increase it to 2. So that means my requirement is like I have no issue starting 2 documents at a time and completing them later. Okay, so in this case let's see how it is done. So this cannot be done using logs. Why? Because logs is mutual exclusion. See, 2 documents started, 2 documents completed, 2 documents started, 2 documents completed, 2 documents started, so last one is the one it started. So it's, so for example if I want like okay 3, now I will do like okay, let's print it here, I'm okay to start, sorry, this is the counter example. Okay, of course it started. Okay, let's do it again. 3 started, 3 completed, 2 started, 2 completed, right? See, that is the reason we call them as, these are more versatile functionality level semaphore. So if I have to talk about the functionality, logs, I would say like these are mutually exclusive. at a time, only one, whereas semaphores are based on the count. So that's the reason these are very versatile primitives. So coming to the functionality, an xlocks is a mutually exclusion one. At any point of time I can give only one, that means there is no count that is being handled here. At any point of time only one thread can access it, it's a mutual exclusion. Whereas coming to semaphores, there is a count that is being maintained. These are very versatile. I can provide the number of permits. In the language of semaphores, count, or it is called permits. You have 3 permits. Okay, so wait, actually what it does is it decreases the permits. Okay, when it becomes 0, that means no thread can be accessible. That's what we discussed in our last video, correct? So that's coming to the functionality. Next, resource count. So pretty much NSLog doesn't have a concept of permits or a specific count associated with it. It provides exclusive access to a critical section and ensures only one thread can enter at a time, correct? Only one thread can enter at a time, whereas semaphores maintain a count. That means the main difference is they maintain a count. Often we refer it as a permit in the language of semaphores. So multiple threads can enter the critical section simultaneously up to available number of permits. So that's basically the resource count means. That means they maintain the resource count. So coming to the functionality at very high level, it's mutually exclusive and semaphores are versatile and based on the count and permits. Coming to the resource count, locks are like doesn't have a concept of resource count, whereas semaphores are based on the permits. So pretty much this and this both are same, but at very high level, functionality level, these are mutually exclusive. And if you talk specifically about the resource count, yes, locks don't have a concept of resource count, whereas semaphores have a concept of permit count. Okay, so next, dynamic permit, correct? So dynamic permit in the sense, NSLog is a simple locking mechanism. It's with basic functionalities like lock and unlock. It doesn't have any additional features or options, whereas as count is available here, we can have a dynamic count. So how we can have a dynamic count? That means here I have defined it directly. Instead of we giving here based on our requirement, actually what we can do is, for example, I have a class, let's say resources, okay, in which I have a private semaphore, dispatch semaphore with no value. Let's say I can define like this also, okay. Or let's wait for so in this, let me have the initializer which is an integer. Then what I will do is, so ignore my code for now, I just want to show you like dynamic count can be. Now I give like boss, I have something initial permit, let's initial permit count it is, let's use the proper language. Initial permit count is this, okay. So dynamically, for example, let's say like this. So just a second, did I add something? Dispatch semaphore, just a second. Dispatch semaphore, okay. Dispatch semaphore, expected member name, not self, no, it's not self. Add arguments, okay. Okay, it's not available in Swift, or let's say not a problem, value let's say 0. So basically, instead of giving a value, dynamically I can assign some value. Dynamically I can assign some value. Just a second. Just okay. Sorry. Dynamically I can assign some value to the semaphore. That means what is the permit count? It's like a dependency injection where I'm injecting when I'm doing the construction in the constructor. That means when I'm initializing this class, I'm giving the initial permit count. So this is called dynamic permit, where this feature is not available in NS logs. So semaphores are often more advanced feature. These are versatile, such as the ability to initialize with an initial permit count. The ability to initialize with an initial permit count and dynamic permit count changes, and the option to use semaphore signals for more fine-grained control. Okay, so this is a special feature of only for semaphores, where I can give the dynamic permit. Not only here at the time of initialization, if I want I can change it, but I can't, maybe I can't change like this. There is nothing called a count or value where I can go ahead and change, but what I can do is I can only reinitialize it. I mean I can only assign it some other dynamic value, whereas for example if it is having some other function, let's say, where from outside, not only in the initializer, if they want to set, if I need to set permits at runtime, I can do the same and I can assign the same. So after a certain at some point of time, if you want, like, okay, let here let only one thread can access it. Okay, after certain point of time, okay, I'm good, let only two threads, handle it. So let it be where, so okay, this is called dynamic permit. So dynamic permit is only available in semaphores. Okay, so this we are good. And okay, what's next? Next one is there is something called blocking behavior. Okay, how they block, and there is a minute difference how they block. And also NSLog uses blocking to handle connection if a thread tries to acquire. So this is the blocking it does. If a thread tries to acquire the lock while it's held by another thread, the thread will be blocked until the lock is released. If increment is blocking it, this has to wait until this unlocks it, this releases it. Okay, it's basically uses blocking mechanism. So blocking behavior of locks is blocking mechanism. Okay, now let's discuss what is the blocking behavior of semaphores. So as you can see, semaphores have a concept called wait, correct? So this means wait they are having, and semaphores also having timeout. Okay, so this is blocking mode. That means other thread has to wait. The thread has to wait if it is other thread has to wait if it is waiting for the resource, but this is non-blocking mode. That means it waits for some time. So basically what it means is it waits for some time, for example 2 seconds or 3 seconds or 4 seconds for a resource. If other thread is not releasing the resource required by so a particular thread, then it moves on and it doesn't wait. It continues execution with the rest of the piece of the code and checks whether the resource is available or not at a later point of time. So that's basically the behavior of semaphore. Why? Because it is having wait with the timeout. Okay, so basically this is with the semaphores. They have wait, which is for the blocking mode. This is blocking mode. Only it has to wait, but here it waits for only certain timeout. Okay, so in the context of Semaphores, non-blocking mode refers to the behavior where thread attempting to acquire a permit from a semaphore does not get blocked if no permits are currently available, instead of waiting for a permit to become available. So the thread continues its execution and can perform other tasks or takes alternative actions. So let's see this with an example. Now I have made the code ready so that we better understand what we are speaking instead of giving you some theoretical knowledge. So what does it mean by blocking and non-blocking? So what I am talking, what is wait with so for example, here I have a semaphore with a value of 0. For example, I have let's say thread, I have thread 1, thread 2. For example, here global queues I have taken. This is my thread 1. Okay, I have 3 threads here. This is my thread 2, this is my thread 3. So here semaphore, thread 1 is waiting for a permit, so it waits for 2 seconds. If it timeout result is whether it got the timeout result of semaphore.wait, it has the return value, it gives you whether it is successful or not. That means it got the access or not. So thread 1 acquired a permit I am printing, otherwise thread 1 timed out while waiting for a permit. So it permitted out, so it continues with execution of the rest of the code. Okay, thread 1 waits for 2 seconds. Like this, thread 2, it just releases it. It's releasing a permit. We'll talk about thread 2. Next, thread 3 is basically waiting for 3 seconds. So it's trying to acquire a permit. It's waiting for 1 second. If it is getting the permit, we are printing like it's acquired the permit. Otherwise it timed out. Otherwise it continuing without the resource. Now let's see. So as it is 1 second, after 1 second it is releasing. So first thread is waiting for 2 seconds. This will get the resource. This will get the signal. Why? Because other thread is waiting for 3 seconds. After that only it is getting executed, right? So after 1 second, when it signals, that means when it releases, when thread 2 releases, thread 1 actually gets the shared resource or a permit. So that's the reason if you can run this piece of code, the example looks very confusing, but the concept is very clear. If you can look at it, what is happening, thread 1 is waiting for a permit. So thread 1 immediately started waiting for a permit, whereas thread 2 started after 1 second. Thread 2 is releasing a permit. Thread 2 released a permit. Okay, now it is waiting for 2 seconds. 1 second is already gone. In the next 1 second, timeout obviously becomes a success. Thread 1 acquires the permit. It acquires the permit and it does whatever it want to do with the permit. Next one is thread 2. Thread 2 also trying, but it is waiting for 1 second. But whereas thread 1 already acquired a permit, but if you can see it, it has not released it. Correct? There is no signal. So this poor fellow thread 3, what it does, it goes to thread, it's trying, it got timed out and it's continuing without resource. That means thread 1 forgot or intentionally it didn't release, it didn't signal. So thread 3, what happens, instead of you blocking complete execution, that means this execution is needed, there are some piece of code after this. Continuing without resource, I can continue without resource, I can wait for, I started after 3 seconds, I waited for 1 second, the thread 1 not released the resource, not given me the permit. Thread 3, what it does, timed out and it is continuing without the resources. Later it will check. Okay, later it will check. But whereas if thread 1, so that's basically the concept of, this is the concept of non-blocking behavior. Non-blocking behavior with the help of wait timeout. Okay, but whereas if thread 1 signals it, that means okay, I have got it, and let's say after if it signals it, now every thread will get the waiting for permit, 2 release the permit, 1 acquired a permit, 3 is trying, 3 acquired, continuing without resource. Now it is not continuing without resource, so it acquired a permit. It acquired a permit. Correct? Why? Because it got the signal. correct? So that's, hope this example is helpful and useful to clearly explain the blocking and non-blocking behavior of a semaphore. See, a thread doesn't wait for a shared resource. If it has other piece of code, it will execute it. Okay, if this particular thread is not releasing, so that's basically the blocking behavior. Locks completely blocks it, whereas semaphores is having a beautiful concept called wait with the timeout, which is the non-blocking mode, using which non-blocking mode is very useful in scenarios where you want to avoid blocking threads and allow them to proceed with their execution even when a resource is not immediately available. It enables threads to make progress. It can make the progress, it can continue without the resource and perform other useful work while waiting for a resource or a specific condition. So dispatch semaphore is obviously, as we discussed, it's a very versatile class, provides both blocking and non-blocking modes through though it's wait and wait timeout methods. By default, wait operates in blocking mode, whereas blocking mode where the thread is blocked until a permit becomes available. However, you can wait to specify a timeout value and make it non-blocking. So that's basically the usefulness of wait with timeout, but it's important to handle the non-block mode appropriately and have proper logic to handle cases where a permit is acquired within the specific timeout period. So that's basically the major differences between NS locks and semaphores. As we can see, one is functionality. Locks are mutually exclusive, whereas semaphores are count and permits based. These are very versatile. Coming to the resource count, NS locks don't have such functionality. They are mutually exclusive. Coming to the whereas semaphores are having a concept called count. Locks are constant, they don't have a concept called count, whereas dynamic permit, a special feature is available in semaphores where at runtime you can change the permits count. And blocking behavior, locks completely based on the blocking behavior, whereas semaphores being versatile, they have blocking mode and non-blocking mode also, which we just discussed with an example. So in general, NS lock is a simpler option for basic mutual exclusion scenarios where only one thread should access a critical section at a time. Only one thread should access a critical section at a time. With the basic functionalities like a lock and unlock, only one thread can access a critical section at a time. Semaphores, on the other hand, provide more flexibility and control when dealing with shared resources that can be accessed concurrently by multiple threads. The choice between NS lock and semaphores depends on the specific requirements of our concurrency scenario, considering factors such as the number of threads that need access, the level of concurrency needed, correct, and any additional features or flexibility required when deciding with which synchronization mechanism is to use. So NS lock being a very basic synchronization technique, whereas semaphores is very versatile, it is having some additional features also. So understanding these differences and features that they provide, we can easily pick one thing based on our requirement, whether we want to go based on mutually exclusive stuff using locks, or blocking and non-blocking behavior and dynamic permit counts using the semaphores. It's up to our requirement. So if we understand these changes, it's very easy to pick up something for our multi-threaded programming. Okay, so I hope this post is useful. Thank you.